I am Kelly Johnston, an Associate Professor at the University of Queensland and Director of their Masters of Occupational Hygiene course. I'm also a member of the AIOH Professional Development and Education Committee, and I'm looking forward to hosting today's webinar on behalf of the AIOH. Before we begin, I would like to start with a welcome to country. We acknowledge and pay respect to the past, present, and future traditional custodians and elders of this nation and the continuation of cultural, spiritual, and education practices of Aboriginal and Torres Strait Islander peoples. In today's webinar, we will hear from 4 great speakers who are all experts in the area of weld fume exposure, but come with different perspectives. We will hear from Bruce Cannon, who's the Technical Publications Manager with Weld Australia. He is a qualified welding engineer and metallurgist. He was employed by BlueScope and the former BHP Steel for 38 years, working in a range of roles, but primarily specialising in welding and related disciplines, including weldability testing and servicing customers reporting welding issues. During his tenure with BlueScope and BHP Steel, he was seconded to a number of special projects, including a period for over 2 years working with the then WTIA as its welding engineer from 1993 to 1995. In this period, he was appointed by the WTIA as its nominee for a range of Standards Australia committees and later represented the Bureau of Steel Manufacturers Australia on standards committees. And Bruce tells me he's still very active on both Australian and international standards committees. We will also hear from Perdita Dickson, and she is the Manager of Occupational Health and Operational Programs with WorkSafe Victoria. She's an occupational hygienist with over 15 years of experience in manufacturing, healthcare, and as a regulator. Perdita joined WorkSafe Victoria as a senior occupational hygienist and moved into the Prevention, Strategy and Planning Division in 2021. We will hear from Halil Ahmet, who is a principal occupational hygienist with WorkSafe Victoria. Halil manages a team of occupational hygienists and is appointed as an inspector under the Occupational Health and Safety Act and the Dangerous Goods Act. Halil has been engaged with WorkSafe Victoria as an occupational hygienist since 1990, and in that time has visited hundreds of workplaces regarding a wide range of hazards, including silica, asbestos, and welding fumes. Halil has provided training to WorkSafe inspectors on a range of hygiene-related topics, including welding fumes and the recent reduction in its exposure standard, and represents WorkSafe Victoria on the Welding Safety Council. And lastly, but not least, we will also hear from Andrew Batterson, who is an Inspector of Mines, Occupational Hygiene, employed by Resources Safety and Health Queensland within the Coal Inspectorate. He has been working in the field of occupational health and safety and industrial hygiene for over 35 years and is a certified occupational hygienist. He has experience across a broad range of industries, although has predominantly worked in mining and minerals processing. This has involved both coal and metalliferous, surface and underground mining operations. Okay, we encourage you to use the chat function to chat amongst yourselves. And if you have any questions, please add these questions to the Q&A tool within Zoom. We will take any questions that you may have after the presentation if there's time. Now, please enjoy today's webinar, and I would like to hand over to Perdita. Thank you.
Thank you, Kelly. And thanks everyone for joining us today. So as you can see, today's presentation is around welding and welding fumes. So I wanted to provide a bit of a quick introduction to welding and how important it is for the Australian manufacturing industry and other industries as well. So welding is an enabling technology, and it is used across a wide range of industries and applications. So it can be used for anything from manufacturing, in healthcare, in transport, and it can be used for not only making new products, but also fixing and repairing items as well. And it is because of this wide range of uses, it is why it is so essential to the economic growth of Australia. So we're going to hear a lot about welding today, so it's probably a good opportunity to talk about very briefly what is welding. And welding in its simplest form is the bonding of two materials together by applying heat or pressure or both? So today we're predominantly going to be talking about welding that bonds those two materials by heat. And when you do that, fumes are generated. And you saw that in the initial picture that we had up. And it is these welding fumes that are really key to what we're doing. So then we'll move on to what those health impacts from those welding fumes. And there are some serious health impacts that can occur from being exposed to welding fumes. And that's the importance of the discussion today. And there's both short-term and long-term health effects. So when we think about the short-term, the predominant health effect that we discuss is metal fume fever. And this is really where people are exposed acutely during the day, and that employees and workers can feel these health effects during the working week, and then on the weekend can start to feel better. And the word fever implies the cold, headaches, kind of symptoms that they will experience. We've got here that milk will not prevent nor cure metal fume fever. And this is a really historical view that's been had, and very interestingly is still to discuss today. The long-term serious lung effects that lung diseases that we discuss range from chronic obstructive pulmonary disease, pneumococcal pneumonia, and lung cancer. And it is really because of this lung cancer that back in 2017, AIOH, or the International Agency of Research on Cancer, declared that welding fumes are a known human carcinogen. And this is from their studies that show that there is a small but significant effect of weld fume causing lung cancer. So because of this, there has been some regulatory change in Australia. So Safe Work Australia, on the 18th of January in 2024, reduced the welding fumes not otherwise specified exposure standard from 5 milligrams to 1 milligrams per metres cubed. And this is a time-weighted average. Now, most regulators have in their legislation a reference to Safe Work Australia, and it's described as published by Safe Work Australia. And because of this, in a lot of jurisdictions, this new exposure standard was immediately picked up. So for example, here in Victoria, we started to enforce the new WES on the 18th of January. And we've done quite a bit of work to support this change, and one of them has to produce a video, and we've got a lovely picture here of Bronwyn, who's one of our senior occupational hygienists, along with an inspector as well, at a workplace who has recently introduced on-torch extraction. And this video really goes through the health impacts of welding and some really great options for controls, and I really encourage you to have a look at that. Now, we are going to move into a poll question. We're going to have 2 poll questions during today's session, and the first one is, how effective do you think welding fume is being controlled in your industry or in the workplaces you consult? And there are 4 options here. So we're going to give you about 20 seconds, and you're going to have a little box pop up on the screen. And if you can answer these questions, it'll be very interesting to see what the outcomes are. And I can see this live, so it is very interesting watching this. All right, if everybody can submit an answer, that's great. And then we will put up the results. Excellent. So I'm pretty sure you can see all the results here. So what we've actually got is that 69% have responded that welding fumes are poorly controlled, 29% saying well, and only 1% saying very well controlled. So this webinar will really hopefully support you to understand what good controls look like, and hopefully provide you with some techniques to discuss that as well. So thank you very much for that. So after this poll, I'm going to pass on to Bruce.
Well, thank you for that, Perdita. A lovely introduction there. Now, I'm going to start by talking about history, particularly Australian history, and then I'll move into the international trends. Now, the history of weld fume control in Australia, or should I say the lack thereof, is somewhat tortuous, but the journey effectively started back in 1982 with the publication of the first edition of the then Australian Welding Institute AWRA Technical Note 7 on health and safety in welding. Many of the hazards associated with welding were well known, and in 1994, it was proposed to produce a standard on the control of weld fume. However, the industry arced up and because they were basically paranoid that the regulators at the time would take this standard and try and enforce the standard. Unfortunately, the standard did not progress, hence the thumbs down you can see on the screen. Interestingly, a regulator said to me privately that irrespective of the debate's outcome at that particular time, the fact that the debate was happening clearly showed that the vested interests were well aware of the implications of their actions and would be held liable by the regulators in the event of an injury to the health of welders. Out of this draft, though, the CRC for Materials Welding and Joining at the time undertook a research project to measure the fume generated in still air from a number of processes. From this work, 16 specific minimisation guidelines were produced and published by the then Welding Technology Institute of Australia. The intent being to assist industry to meet their obligations to protect the health and safety of welders and operators from fume perspective and meet their obligations under the then hazardous substances regulations. They cover quite a range of processes from manual metal arc right through to brazing and soldering. In February 24 this year, these guidelines were revised and updated to consider the new 1 milligram per cubic metre TWA fume limit, and in a 17th guide was added to provide some guidance on arc air gouging. Importantly, these guidelines are referenced in the various codes of practice developed by the regulators. Now, moving to international trends. Next slide, please, Kelly. The IIW Commission 8 on Health and Safety, their chair attended, can we go back one, Kelly? The Health and Safety Chair attended the IARC deliberations, which has given the Commission a valuable insight into the studies evaluated by IARC itself. Commission 8 reviewed the IARC report in detail and formulated a position statement based on the IARC data. Their statement confirmed the IARC position and has confirmed that previous 2003 advice that the exposure to welding fumes should be minimised and at least to national guidelines. Unfortunately, whilst IARC has reclassified weld fume, it has not offered any advice to the industry or regulators on how to deal with the situation. Further, the studies used by IARC did not report on fume control strategies used by welders associated with these studies. Being mostly shipyard welders, it is unlikely that there were any fume controls beyond a natural breeze, if at all. Now, the USA engaged a specialist to review the data utilised by IARC and prepared their own position statement. Now, their current advice is to continue to follow the AWSZ 49.1, which you can download free of charge from the AWS if you want to have a look at it. In other words, natural ventilation is okay if they keep the welder's head out of the plume and comply with exposure limits. Their advisor questioned IARC's conclusion because of the inconsistency of risks reported in the data. However, it should be noted that Dr. Scheischer, who attended the IARC deliberations on behalf of Commission 8, has respectfully disagreed with their conclusions. He has also reported that ongoing evaluations of studies is confirming IARC's position. Now, in Germany, they now recognise lung cancer in welders as an occupational disease. This has only just happened. Europe in general, though, has been slow off the mark in dealing with weld fume as a carcinogen. Only now are they considering adding weld fume to an existing directive. The Netherlands, though, have had a 1 milligram per cubic metre limit since 2012, and Germany now have a 1.25 milligram limit. Now, in the UK, the regulators have taken a very different approach. The Health and Safety Executive initially issued a directive for all welders to use air-fed helmets to minimise fume exposure. However, this has not proved to be practical. They have now provided a more measured response and depending on the situation, it can vary from general ventilation through to requirements for the use of local exhaust ventilation and personal respiratory protection. I have noted, though, that the UK does not have weld fume exposure limit per se. Rather, they have utilised workplace exposure limits for the various components of weld fume for over 20 years. For example, the iron oxide well is currently 5 milligram per cubic metre. Now I'm going to pass across to Andrew now, who will talk about the exposure monitoring in the Queensland coal mining industry.
Thanks, Bruce. So what do we know about exposures? What does all this mean? There are a few jurisdictions in Australia that systematically collect exposure monitoring data for welding fume. This gives us an oversight of what exposure to welding fume actually looks like, and we can compare this data with exposure limits to indicate what the risks look like. The Queensland Coal Inspectorate under Resources, Safety and Health Queensland have been collecting personal exposure data from coal mines for a number of years now. The data is collected on an annual basis and the results are analysed and then a summary report issued back to the industry to share information and inform stakeholders about exposure risks in their industry. While this data only reflects exposures to boilermakers working in the coal industry, and this is relevant to the type of welding methods and materials used, it provides a valuable insight into welding fume exposure when applying these methods. For example, the welding is primarily for maintenance and repair purposes and doesn't include construction and fabrication, which may use different methods. I'm going to give an overview of the types of welding methods used in the coal industry in Queensland, and then share some of the exposure monitoring data with you. Next slide, please. So this chart gives a bit of a brief overview of the types of methods used in Queensland coal mining. Activities are predominantly directed at repairing and maintaining either fixed plant structures in processing facilities or on heavy mobile equipment used for mining. This dictates the types of welding methods used. These are predominantly MIG, or using flux cored arc wire through MIG machines with shield gas, which is predominantly argon inert shield gas, typically Argo Shield 52. There's limited application of other weld methods, including TIG, and particularly stick, which is used typically for short durations and for minor jobs only. Majority of material being welded is mild steel with some hard facing and bisalloy. Welding of aluminium, stainless steel and GAL is relatively rare in this industry. Another important factor to consider is the location where the welding is performed. Most of the maintenance welding is performed in situ, out in the field where the equipment is located, and these are typically in outdoor environments. Welding inside workshop environments is relatively rare and to a much lesser extent than outdoors in natural ventilation. The current database that we have comprises of results dating back to 2017 up to December 2023. There are approximately 2,000 samples in total, and these have been reported from around about 52 separate coal mines over a range of different segs. The monitoring includes both task-based and full shift monitoring. Some of the task-based samples range from minutes to hours, whereas the full shift sample durations are from 8 to 12 hours. Monitoring is conducted with IOM inhalable sampling heads. These are typically positioned on the boilermaker's lapel and in their breathing zone, although not behind welding shields, because typically the boilermaker is wearing PAPR type systems. Therefore, the results we would say are representative of unprotected exposure. This is a graph that shows the average welding fume concentrations across all of the mines that report data to Resources Safety and Health Queensland. This data typically includes full shift monitoring data. Each colour represents a different mine or a different site. Each of the vertical bars represents the average concentration of welding fume exposure to welders in the boilermaker group. The previous exposure limit is indicated by a dotted line at 5 milligrams per cubic metre, and you can see that the levels are consistently below this. But remember, these are average concentrations, and many of the single sample levels are much higher than this, and particularly the UCL 95% values often go above the 5 milligram per cubic meter limit. We then just further the slide. You can see there, if we superimpose the line that represents the current limit of 1 milligram per cubic meter, all of the sites except for one now start exceeding the exposure limit of 1 milligram per cubic meter. If we then also apply the rule of thumb for good hygiene practice, and that is that we control exposures below 50% of the limit, you can see that all of the mines will be above that exposure limit action level of 0.05 milligrams per cubic meter, sorry, 0.5. This next slide shows what the exceedance rates look like for the same data set. This includes both full shift and task-based samples, ranging from 2018 through to 2022. We see that for the green bars there, 30 to 40% of samples exceed the 5 milligram per cubic meter limit. 60 to 70% exceed the current limit of 1 milligram per cubic meter, which is in black, and 80% exceed the current recommended action limit of 50% of the OEL, which is in red. The typical exceedance rates for respirable dust and silica in the mining industry sits at around about 1 to 2%. Remember, this is considered a dusty industry. So if you compare that with dust, these levels of 60 to 80% exceedance for welding fume is a pretty stark comparison, and indicates that we've certainly got an issue with welding fume. But it's not only the mining industry, it's all other industries that are applying the same types of welding activities. I'll now hand over to Halil, who's going to give us a perspective from the Victoria context.
Thanks, Andrew. Some great data that Andrew has there, and unfortunately Victoria hasn't got that level of data, but we have got information on a range of workplaces, and we do know that mainly manufacturing and construction are undertaking welding type tasks. We believe mostly MIG is being undertaken, and we certainly already know that the welding activities are covered under the HAS subs regs in terms of the employer duties, not the manufacturer supplier, but the employer duties. Pretty black and white or stark sort of statistic or fact is the fact that since 2019, 3 Victorian workers have died due to diseases caused by welding fumes. Unfortunately, we don't know the background to that. Trying to dig a little bit more, but it's a statement in itself that should be, people should stand up and listen to. We have got guidance, and our guidance controlling exposure to welding fumes covers a range of information. It's quite a large document. It's quite a good document, if I say so. And it has been upgraded in recent times to capture the reduced exposure standard of 1 milligram per meter cube. It's also, just last week, upgraded to the digital version, captures the video that Perdita was referring to, that Bron from the hygiene unit is in as well. It's a very good video. It came about as a result of an employer implementing on-torch extraction as a result of some intervention from WorkSafe, and it's their explanation of the story of their sort of traveling down the path of introducing that extraction and how effective it is for them as well. So we've had our eye on welding fumes as an organisation for a while, but the reduction on 18 January 24 from 5 to 1 really sort of prompted a lot of the project work that we're now undertaking. So next slide, please, Kelly. So the project that we're undertaking is really focusing on workplaces that we have identified as undertaking welding tasks. It's a snapshot. It's about 170 to 180 workplaces that we've collated. Part of the project has involved briefing the inspectors involved in that project, but we've gone beyond that. We've briefed all of the inspectors, so all of our generalist inspectors, sort of regional, suburban, major hazards, construction inspectors, etc. We brief all those groups because they will always come across welding type issues. So they've been informed in terms of the lower standard, what that means. There's some tools that we've developed to assist them in determining whether controls are required or whether air monitoring should be undertaken, etc. We've also created some standard phrases or tools that the inspectors can use. And part of the project involves a hygienist, a WorkSafe hygienist, assisting the inspector on the visits. So initially, a couple of visits with the hygienist. If the inspector feels comfortable, they can carry on without the hygienist. If not, they can undertake the rest of the visits with the hygienist. So it's a great experience in terms of an education process for that inspector as well. When in terms of the visits, some of the visits, sometimes when we undertake the visits, the employer is already expecting us. They're saying, we were wondering when you were coming. Others are aware of the reduced exposure standard. Some are either industry associations or union associations. And we are establishing that what we thought in terms of MIG welding, it is mostly MIG welding that we're dealing with. Some stainless steel and some TIG welding, I should say, in some processes, but mostly MIG welding. In terms of stats, for the time being at least, as of Monday of earlier this week, there's been about 60 visits undertaken, 43 workplaces, so some double ups there. 40 notices have been issued. Most of the notices are related to controlling the risk in terms of welding fume exposure. And the emphasis that we are putting on workplaces is that the control needs to be in relation to as close as possible to the source. So we're talking about generally on-torch extraction. We are pushing on-torch, but we are realistic in acknowledging that in some cases on-torch is not going to be practicable at the same time. So we might go into a workplace and they've got respiratory protection, but if we believe on-torch is a more appropriate control to implement in accordance with the hierarchy, we are pushing on-torch. Some notices that the inspectors are issuing are in relation to air monitoring as well, and the other notices cover HAZSUBs registers, DG storage requirements, and some housekeeping as well. I might hand it over to Bruce at this stage to give you a little bit more, but on the Australian context.
Thank you, Halil. Just to start with, I'm just going to talk about the fume minimisation guidelines. Next slide, please, Kelly. Thank you. This is the document I was referring to earlier as the fume minimisation guidelines. This edition was published in February this year, and it's available free of charge from the Weld Australia website. You can, if you remember the address that's shown there, good luck. Otherwise, just go to weldaustralia.com.au and follow the links to resources and then the technical guidance notes. Next slide, if we could, please, Kelly. Now, looking specifically at the weld fume generation, the guidelines show that all arc welding processes produce fumes, some more so than others. Now, the level of fume produced will vary with the conditions of welding. Looking at some of the relative fume generation rates, it's very important to note that the weld and related fume is not always visible. And it's not visible, and the non-visible component is potentially the most hazardous because of its particulate size. Now, this graphic is modified from a similar one published by the Australian Cancer Council to reflect the fume emission rates determined during preparation of our guidelines. Now, the composition of the weld fume generation is mainly dependent on the composition of the consumable itself, which includes the fluxes if present, and any coating the welder is welding through. Now, consumables for carbon steel will emit oxides of iron and manganese primarily, but alloyed wire may contain additions of chrome, nickel, and molybdenum in particular. Hard-facing consumables may contain additions of tungsten, cobalt, and high levels of chrome. Actual composition and hazards associated with each consumable can be found by referring to the safety data sheet supplied by the consumable manufacturer. For those unfamiliar with ozone, it is formed by the action of the ultraviolet radiation from the arc on atmospheric oxygen, and where there is a lot of surface UV reflection, ozone can be found accumulating away from the arc. And that is particularly the case for stainless steels and even worse for aluminium. It should be noted, though, that consumable and other power source manufacturers are doing a lot of research to minimize fume generation rates through what's called waveform controls applied to the gas metal arc and flux cord arc process groups. Of particular note, fume generation rates for thermal cutting can also be very high, and unless the process operator can keep their head out of the plume, the fume generated is potentially problematic. Now, if we look on the next slide, you can see worst case scenarios as far as fume and emission rates that were measured in still air during the development of Weld Australia's guidelines. Interestingly, the work demonstrated that most, if not all, open arc processes required a measure of fume control primarily to manage the ozone generated when these numbers were first generated. Now, from the fume particulate perspective in still air, the fume levels generated will be high in many cases. But as I've stated previously, the fume may not be readily available or visible to the welder, and I should add, it may not be visible to the observer either. The next slide, please. Now, by way of example, shown here is the result of summary for gas metal arc, or the MIG-MAG process as it's known as in Europe. Included are recommendations on the minimum required fume control methods. For this process, the use of fume capture devices may be necessary to protect the welder. An additional protection may not be necessary to protect the operator, provided clean air movement is greater than 0.5 meter per second across the welder's breathing zone, and the welder's head is not in the plume. And I stress, not in the plume. Be aware, though, that care must be taken to avoid excessive drafts, as it can remove the gas shielding from the arc and cause welding defects, including porosity. Accumulations in the fumes in the workplace must be prevented at all times. And so adequate general ventilation is essential, or otherwise not only will the 1 milligram limit be exceeded, so will the old 5 milligram per cubic meter limit. And next slide, please. Now, one of the things that we have done is provided guidance on a process risk assessment associated with the fume minimisation guidelines is managed. Importantly, whatever process is used to assess the risks and manage the hazards, the process used must be documented and the results of the assessment recorded. Now, if we move to the next slide, we will see that applying the guidelines is straightforward, and these simple diagrams show how the workpiece should be positioned to minimise the welder's exposure to fume. It is important to note that if the welder cannot keep their head out of the plume, which is likely depending on the position of that welding is actually taking place. If it's downhand, the welder's head will almost certainly be over the top of the job, but if it's out of position, the head will be away from the plume. The welder will most likely require a level of personal fume protection, or PPE, because the level of fume likely to penetrate the welder's breathing home will send the welder into an exceedance. Now, Perdita will now talk about the regulations that we're now dealing with. Thank you, Perdita.
Thanks, Bruce. So we're going to start getting into some of the legislation. Can you just go back a slide, please, Kelly? And I'm just going to start with where we sit with the regulations and with the legislation in general. So I've got WHS here, and for most of you who live outside of Victoria, you are working with the model regulations. Us in Victoria still have our OHS legislation, so this is based on the model legislation. But it's very similar to what we've got here in Victoria as well. And what it requires is that the PCBU, or the employer, is required to eliminate all risks associated with health and safety, or if it cannot be eliminated, being minimised so far as reasonably practical. Importantly, and Halil touched on this before, welding fumes are identified under the hazardous substances regulations for us, or HAZCAM regulations under the model legislation, and that then requires a number of employer duties to occur. And one of those is that they must identify the risks and hazards to health, so that they identify that there is a risk from the welding fumes. They also must not exceed the exposure standard. There are certain situations where they need atmospheric monitoring, and Halil will talk about that later. And this is probably the main part that we're going to talk about now, is that risks must be controlled, and if required, they may need to be reviewed and revised as well. So I'm just going to now move on to the hierarchy of control and provide a really clear understanding of what that is. So we probably all use this word a lot. And the legislation, and this is the Victorian legislation, which is similar to the model regs as well, have a very specific flow to them. So first of all, you must eliminate any risks associated with welding fumes. However, if that is not reasonably practical, and I'll go into what that is at the next slide, you must reduce the risks with one or more of the following. And those three are substitution, isolation, and engineering controls. If it is not reasonably practical, or the risk is not fully controlled with those controls, we then move into administrative controls. And then finally, we get to PPE. So PPE is where it is not reasonably practical to implement the control above, or they are still required to support the reduction of the risk further. So that is what the hierarchy looks like, and it is a really important part of our legislation, and I think Halil alluded to it earlier. It's a really key thing when we go to workplaces and discuss what are reasonably practical controls. So the next slide, please, Kelly, talks about what is reasonably practical. And this is really core to what we do, and it's really important for people to understand. So when you're determining if something is reasonably practical, you have to give regard to the likelihood of the hazard or risk eventuating, the degree of harm that would occur, what the person concerned, so the employer, knows or reasonably know about the hazard or risk, and any ways of eliminating or reducing that hazard or risk, the availability and suitability of ways to eliminate or reduce hazard or risk, and lastly, the cost of eliminating or reducing the hazard or risk. So this is importantly also an objective test. And the standard is the behaviour expected of a reasonable person in the duty holder's position and is committed to providing the highest level of protection for people against risk to their health and safety, and that they are proactive in taking measures to protect the health and safety of their people. So these are very strong words and very core to what we do. And WorkSafe has guidance around reasonably practical, and I'm sure the other regulators do as well. So this is maybe something for yourself to consider to understand a little bit better. So I'm now going to hand over to Bruce, who's going to start us off on our hierarchy of control with elimination and substitution.
Thank you, Perdita. Good introduction. Now, I'm just going to mention that all arc welding produces fume, as I mentioned earlier, and control requirements will vary with the work site. Keep in mind that a combination of controls may be required. Now, removal of the welder from the arc source reduces their risk of exposure, and that is preferably the best way to proceed, but that's not always possible. Another alternative is that you can use processes that produce reduced rates of fume, and this may be a viable option. This is particularly potentially viable if you're using the gas metal arc or MIG process, where waveform controls, for example, can reduce the fume generated by up to 70%. I should add that the lower emission welding consumables are also now being developed by consumable manufacturers. Now, in the next slide, this slide now shows clearly some benefits from applying waveform controls if the power source is fitted with such an option. Now, this option is typically available in the better quality inverted power sources, particularly for the gas metal arc or MIG welding, where waveform controls such as control dip, which includes variants marketed under a range of names, some of you may know them, CMT is one, LSC, RMD, or probably the STT is the one that's best known. Or in the higher current process, it's generally known as pulsed welding. And this can reduce the fume generated by up to 70%. Now, if we look at the top two photos in this slide, you can see the effect very clearly with conventional spray mode welding on the left and pulsed mode welding on the right. Furthermore, it has been established that the level of carbon dioxide in the shielding gas can also have a profound effect on the amount of fume generated. Now, reducing the carbon dioxide content from 18 to 10% in this particular example can nearly halve the level of fume generated. Now, obviously, it's not going to eliminate it if you get rid of all the CO2. But it should be noted, though, that reducing the CO2 content of the shielding gas may not be feasible from a technical perspective, as it can adversely affect the weld metal properties and classification of the welding consumable. Watch this space, however, for future developments, no doubt. Now, Halil will now talk to you about the local exhaust ventilation issues, or LEV systems. Thank you, Halil.
Thanks, Bruce. Yeah, I think there's a lot to come with waveform and CO2 shielding reduction. So I think it's one area that if people get the opportunity to explore, they really should. But the next one of the other options in the hierarchy is engineering controls, and local exhaust ventilation slots directly underneath engineering controls. So as I said, in terms of the project we're running at the moment in Victoria, we are focusing on on-torch as a key option for workplaces where a control is required, and that's because it captures the fumes at the source. And we're appreciative of the fact that in some cases on-torch isn't practicable. But as Perdita mentioned, you've got the hierarchy, and you have to consider engineering controls before you start proceeding down that hierarchy to your last option, which is personal protective equipment. And as good as powered air purifying respirators are, you need to consider controlling it as best you can at the source. So the workplaces that we're going to, some of the workplaces are talking about, the on-torch guns aren't that great. I tried them out 20 years ago or 10 years ago, and they are much better than what they were. So they're better designed. The problem with drawing away the shielding gas isn't what it was before. The capture can be effectively established to effectively capture the fumes without disturbing the weld itself. And they're much better in terms of ergonomically designed, and in terms of being able to actually see the weld and when you're undertaking the task. The diagram on the left, if you haven't seen one of these guns before, the diagram on the left sort of shows you where the nozzle slots are, where the fume is drawn away. So it's really almost directly at the point where the arc is being struck. So it's really a great way of controlling the fumes. Next slide, please, Kelly. Actually, the one thing I should have said, that in some cases you can, not in some cases, but you can actually get the on-torch unit plumbed into a fixed system as well. I should have mentioned that before. So after on-torch, you've got your sort of other standard, if you like, extraction systems, your mobile extraction units, the bottom left, the blue dot unit there is your mobile type of unit with a flexible arm. The fixed extraction units with flexible or fixed arms in the center there, where you can sort of move around the hood and into a position. And then you've got sort of your bench top with a fixed system with extraction system there on the right, with the red sort of and black cabinet there. And they can be very good where you've got a straightforward and single type item where you're introducing into that bench top extraction system, undertaking the task, the welding capture velocity is effective, it's set, and then you just remove it and you introduce the next item to weld, etc. Also got a couple of, I know this is a very crowded slide here, but there's a couple of photos there of a welding task being undertaken. And the top one is showing the fumes that aren't being captured by the hood. And the bottom photo is the same task, same process, showing how far away that hood is from the task. And really, the hood shouldn't be further away than roughly 30 centimeters, and sort of diagonally, sort of above and across from the weld point or the arc point. But in this case, the welder was doing like a meter and a half of welding. He was slightly on an elevated platform, couldn't move the hood, and it was a very stiff hood, sort of extended ducting to move as well. In the end, this workplace was pushed to on-torch extraction, and that's the direction they went for this particular type of process. So it's just some examples here. The UK's HSE's welding fume control WL3 document, a very good document that's worth looking up. It has got this table in it that I thought I'd highlight, and it's sort of quite consistent with the way we've instructed our inspectors. And if you notice at the bottom there, it's talking about a 1 hour per welder per shift. And sort of the reviews we've done, we sort of are looking, we advise inspectors as a general rule, not as an absolute rule, but as a general rule, to start looking at if welding is being, or arc time, and it is arc time, is greater than 1 hour, then they should start looking for a control. A control needs to be introduced into that process. And it's trying to equate with what we've seen so far, that generally for sort of standard MIG welding in a relatively open area, more than 1 hour is likely to get above the standard. But as I said, that is a general rule of thumb. And this document, the UK's document, is sort of applying a similar approach. It's using the 1 hour per welder per shift in terms of arc time and pushing people to extraction systems. So I think it's a worthwhile document to have a look at if you haven't already come across it. Next slide, please, Kelly. So any extraction system, any engineering control, you need maintenance to ensure that it's operating effectively. So a checklist or a check program should be put in place. Then that might involve daily visual assessments and weekly and monthly checks as well. With some units, because they are quite detailed, such as an on-torch system, would recommend going back to the supplier and the manufacturer to assist with creating that checklist. They would have some basic checks that you should be doing, and that should form part of your overall check system. Simple assessments, just a visual assessment of fume capture, might even be worthwhile putting up diagrams, or sort of, I should say, photos of poor capture and showing the welding fume and good capture, and the positioning of the hood as well, if it's a mobile type hood, or the positioning of the item if it's a fixed hood, of how close it should be. So that's a visual assessment for the welder to always take into account when they're undertaking the task. Other simple assessments are sort of, is the hood positioned? Is it flexible? Is the condition of the duct appropriate? Twists and tears, etc. And then the capture hood and the flexibility of the arm. The capture velocity, it should be at a certain flow rate and sort of 0.5 meter per second generally. And then there's transport velocities for the ducting of the system as well. Next slide, please, Kelly. Also worth remembering that for portable units, there's going to be a case of emptying out the capture, the weld fume that's being captured, the particulate. And some units have got are alarmed, visible alarms, or sort of gauge alarms, or sometimes audible, but the operator needs to be trained up on how to use these and what it means and what to do, the actual method of emptying out these units as well. So it's very basic, but the employers, all welders, should be trained in all of this process. It shouldn't be assumed that they would know. And there's just some diagrams here that just demonstrate just poor maintenance. You know, the item on the left in terms of the flexible part of the ducting, a massive hole, somewhat effective, but wouldn't be very effective. And the other unit on the right, you can't see it possibly all that well, but towards the top there, it's actually split. The ducting is split, so it's sucking away the fume possibly from the source where it's being generated, but it's most probably just blowing it back into the environment that it was working, that it's surrounding. So simple thing, but it's a big part of your operating system, just the maintenance of the items and the checklists. I think I'll hand it over to Perdita to talk a little bit about the next or the lower rungs in the control hierarchy in terms of PPE. Thanks, Perdita.
Thanks, Halil. So yes, I'm going to talk about PPE, which, as we've discussed, is the last option as per the hierarchy of control. And really importantly, you must consider that all welders obviously need to use a welding helmet. So you need to think about how is that respirator choice going to work with the welding helmet. And because of that, there's probably really only 3 options that are likely going to be available to welders. They are half-face disposable respirators, half-face reusable respirators, and powered air purifying respirators, which are the more practical choice, and I'll talk about them in a second. But importantly, with all of these respirators, is that you need a minimum of the P2 particulate filter, because these are obviously thermally generated particulates. Also, there needs to be a consideration of the organic vapor filter to protect from ozone. I'd like to point out to everyone that there's a recent study from AWS, which is called Protecting the Welder from Ozone, and this is something that you can have a look at and consider as well when thinking about ozone protection. Thanks, Kelly. So powered air purifying respirators, these are realistically the more practical option for welders, and we see a lot of them out in many workplaces, and there's a picture that you can see over there. They do provide a high level of protection. They also mean that the welding helmet and the PAPR is in one unit, which makes it quite effective. And also because there is no seal for most of them, facial hair will not affect the protection that they provide, which is obviously very beneficial for many of these users. However, it's really important to remember that these are the last option of the hierarchy for a number of reasons, because they really rely on the people using them to use them correctly. So for one example, I mean, Bruce has spoken a few times about the fact that a lot of these fumes are invisible to the eye. So what will happen quite frequently is someone will do a weld. As soon as they finish, they quickly flip up their visors. At that point in time, that person is completely unprotected and they are then being exposed to those welding fumes. So if people are using PAPRs, it's really important that they're informed of this and they're trained and supervised to ensure that they're not flipping up their welding helmets immediately. They also really need to have a system of work to maintain these systems. And so for that, for example, it might be doing weekly checks to ensure what these look like. And the next slide will show some pictures of whatnot's great. And also things like, for example, a schedule for changing filters. If people are reliant on their PPE, their PAPRs, these need to be used effectively to ensure that they are providing the correct protection that they need. So Kelly, if you pass to the next slide, you can see some examples of what can frequently happen with PAPRs. So in particular, the hoses can quite often become quite damaged, and you can see that in these pictures. Thank you, Andrew, for these. And also what we see quite often is that potentially a lot of the material might have become degraded, filters may be out of date, or if they are using organic vapor filters, they haven't got any knowledge of when they last changed them. So these are some really common issues that we do see with powered air purifying respirators. So we are now going to move into our second and last poll. So there's a few more options with this one. So after we've been through all of these items, what is the most common control measures you see for welding fumes in your workplaces that you either work in or the ones that you consult with? And so you've got a number of options there, and there's just one to select. So I think you'll have about 20 seconds again or so to select your answer. We'll have the results up soon, so a few more seconds to get everyone to put their answers in. I think, can we all see the results now? I can see the results, but I can see them live. Here we go. We've got the answers up. So I'm not surprised by these answers, to be honest. And we do see that powered air purifying respirators on their own are quite often the only control that workplaces have in place. So hopefully, as you can see by this, from this session today, that as per the hierarchy, but also to ensure not only just because of the hierarchy, but also to ensure that the risk is being controlled effectively, those higher order controls are really important. We've got here that we've only got 1% of people one person has only ever seen on-torch extraction or on-tool extraction. And again, I'm not surprised by that, but we're really moving into a phase now, as Halil said, particularly in Victoria, where this is what we're discussing with workplaces. It's really encouraging to see 15% of people saying they're seeing that combination of LEV and respiratory protection. And to be honest, that is what we would be looking to see. So thank you. It's a really good representation of what you're seeing out there. So I'm now going to hand over to Bruce to talk about how controls are discussed by Weld Australia as well.
Thank you, Perdita. Now, in terms of weld fume minimisation and control, what does Weld Australia actually recommend? Well, after consultation with Commission 8, it has been established that the fume minimisation guidelines and the published recommendations within our Technical Note 7 remain valid. Now, I'm not going to go through each of them. However, it is recommended that a risk assessment be conducted and documented. A number of considerations must be applied when identifying the appropriate controls, and these are summarised on the slide. Now, note that the effectiveness of fume capture devices is limited and typically does not exceed 90%, possibly much lower in some cases. Now, a combination of controls may therefore be required to meet the 1 milligram per cubic metre limit. Now, a good overall ventilation system used throughout the workshop in conjunction with fume capture systems is essential for the protection of personnel working in the vicinity of welding. Now, this includes the welder. To ensure conformance with the 1 milligram per cubic metre exposure limit, the use of supplementary personal protective equipment is likely to be required in addition to the use of capture devices and good ventilation, especially if the welder's head is in the plume. Importantly, the fume must not be allowed to accumulate, including in areas away from where the welding operations are underway. And when you require, specialist advice is always available from occupational hygienists to evaluate the effectiveness of the fume management strategy adopted. Now, I'm going to deviate slightly now and talk about safety training. Now, on the next slide, you can see here that Weld Australia has produced a course aside from our fume recommendations, and it's designed to assist a range of welding and welding related personnel to understand the hazards of welding. This particular course is available and accessible free of charge to everyone, and it's available online at the site that's shown at the bottom of the screen. Now, this particular course consists of a range of videos and downloadable student notes. Simply access the training module via the link shown. New users will need to create a free account and then log in to access the course. Now, the welder course consists of 13 modules and the supervisor level of further 6 modules. Now, one of the reasons why I'm mentioning it today is a hygienist in particular contacted Weld Australia after completing this particular course, not knowing much about the hazards associated with welding. They undertook the training course and found it of such great value that they are recommending it to other hygienists. They should go online and do both sets of modules. They have since inquired about undertaking more extensive training, such as our welding fundamentals courses. Now, registered professionals, I should add, can claim CPD hours by undertaking these courses. So not just hygienists, but also engineers and the like as well. Now, Halil will now talk to you about when is air monitoring required. Thank you, Halil.
Thanks, Bruce. I would highly recommend people jumping onto those courses. They are free and definitely worthwhile doing. I also want to comment on the chat. Someone was talking about LE on-torch extraction and not being that great from some of the welders, and someone has commented saying it's about calibration, and I think that is key. It's really getting the suppliers out to set it up and train your operators to ensure that it can work effectively. Okay, so in terms of air monitoring, Victoria and the WHS regs have got the same or very similar requirement, and what it is, an employer has to ensure that atmospheric monitoring is carried out if there's an exposure standard, but then there is uncertainty as to whether the exposure standard is or may be exceeded. So there's the second part of that where atmospheric monitoring is necessary to determine whether there is a risk, but where there's usually an exposure standard, that's the sort of the biggest guide, the part A. And you can see it's not saying you must always do air monitoring. It's saying where there's uncertainty whether the exposure standard may be exceeded. So if you walk into a workplace, or if you're at a workplace where it's obvious there's very little exposure, e.g. it might be a robotic process, or you're observing the activity and there's it's all being effectively captured at the source, I should say, and there's very little fume that's either generated in the employee's breathing zone or in the workplace itself. No need to do any atmospheric monitoring. You can go through, you can just say your controls are adequate. But if you walk into, and then the converse of that is if you walk into a workplace and there's fume everywhere, you sort of ask a question about how long someone is welding or how long the arc time itself is. And they start saying 2 to 3 hours, and you're observing the work practices, and it's going through their breathing zone and sort of spreading it beyond that as well. Then once again, no need to do air monitoring there. Really, in terms of legislative requirements, you should straight be going to control. And then once you've implemented control, there may be a need to come back and review how effective it is. Like, if there's uncertainty, then maybe do some air monitoring to establish, is there a risk still in this workplace, and does further action need to be taken? Next slide, please, Claire. Thank you. So who should do the monitoring? And it's really a person who's got appropriate knowledge and skills. Now, normally we are talking about an occupational hygienist coming in and undertaking that work. If you're not sure, ask to see a past report, and they can blank out the report, not identified a workplace that they've provided reports to, etc., but to see that they can undertake that sort of work, can produce a report that's reasonable and comprehensible as well. Ideally, they should be looking at monitoring over a full shift, or at least over a long enough period that they can extrapolate to understand what exposure is likely to be over that full shift as well. They should understand the process before they come to your site. You don't want someone coming to your site for the first time, or coming to your site and asking questions and taking up time to sort of go around and understand what's going on, and so much so that they're digging into the monitoring time and sort of it's just depreciating the value that you're getting out of them. So whether it's sending them photos beforehand, getting them to come out and do a walkthrough beforehand, ideally, that's what should occur. They should do a walkthrough of the workplace beforehand, but they should have a very good understanding of the repetitive nature of the work, the type of welding, the frequency, the duration, the number of operators, etc. The other thing is, we see a lot of reports, and often you look at the report and there's no real description of the process. And then when you query it further, you understand that the person undertaking the monitoring set up the monitors and then came back at the end of the shift and just took the monitors away. Now, there's a real lack of understanding of what's actually occurred during that monitoring period, and it's really critical to be able to observe what's going on, to be able to make some practical recommendations, I should say, of why exposure is occurring, or the work practices. Yes, the hood might be there, but the method is that the person's not moving the hood, or it's not really realistic to have a hood in that sort of setup because it's constant movement. So it's those sort of observations that are critical to include in the hygiene report. We encourage measuring for constituents. Currently, the way the exposure standards are set up, like you've got the 1 milligram per metre cube for welding fumes in general. Generally, if you monitor to that, you're probably going to be okay. You're most likely going to be okay. You should still justify it by knowing what sort of other contaminants they might be coming off, and understanding that they're not likely to exceed the exposure standard. This is the consultant that's undertaking the work, or the person undertaking the monitoring. But we do recommend that you do undertake constituent monitoring as well. And it's mainly because, come 1 December 2026, many of those are going to change. And Perdita will talk about those changes later on. So if you start monitoring for them now, you know what you will have to deal with. And if you have to significantly reduce exposure, then you'll have to start sort of putting something into train now. Next slide, please, Kelly. Yeah, so worthwhile, definitely worthwhile. If you haven't had a look at it, the AIOH guidelines for writing an occupational hygiene report, it's currently 3rd edition. I think it's going to be revised fairly soon, but definitely worthwhile having a look at to see what a report should look like if you're from a workplace, and if you're undertaking hygiene and monitoring, to see that it's consistent with those guidelines. There's also a very good video on the AIOH website, a masterclass in report writing by Linda Apfel, and it does talk about the nitty-gritty of what should go into a report, and it's really valuable, I'd say. We see some reports where it's not clear when they're talking about exposure, whether they've monitored for 4 hours and they're representing just the 4-hour monitoring period, or whether they've extrapolated that to a full shift. Like, it's certainly worthwhile including the monitoring, the concentration for the monitoring period, but then you should be looking at extrapolating to the full period, for the full shift as well, whether it's an 8-hour or whether it's whatever the equivalent shift might be. And then specifying the conditions, the welding type, the metals, the parameters, etc., so that in a year's time, if someone comes back to that report, they know exactly the conditions under which the monitoring was undertaken, and if they're undertaking further monitoring at that point in time, it's comparing apples with apples as well. We absolutely encourage people to have the report explained to them. If I've commissioned the report, I should get the person who's produced that report to explain it to me, so I've got a clear understanding of what it means and what control actions I may need to put in place. And we certainly encourage that the person who undertook the report presents it to the people who have been monitored. So in this case, the people who undertake welding, and that gives them the opportunity to ask questions, and usually enables the implementation of the controls that might follow to be a bit more of a smooth transition, because they're part of the whole process as well. Okay, so that's my section. I'll hand over to Andrew now to talk a little bit about the monitoring in the coal mines industry. Thanks, Andrew.
Yeah, you remember the data that I shared at the start of the webinar earlier on? This stuff started being collected back in 2021. And it was at that time that we realised the need to develop guidance for our industry in how to monitor and also to control welding fume. So why develop the guidance note? What we found in that data was a lot of inconsistent methods. Sample durations for task-based range from less than a minute up to 6 to 8 hours. And the full shift stuff ranged from something like 6 hours up to 12 hours. So there's a lot of inconsistency in the way the samples were collected. The results indicated that although it was inconsistent, a lot of the results indicated exposures were much higher than the existing limit at the time, which was 5 milligrams per cubic metre. We went out and did a couple of years of compliance type structured inspection surveys across about 50% of the coal mines in Queensland. And from that inspection regime, we discovered also that there was a heavier reliance on PPR respirators. And there was poor compliance to wearing respirators. Out of the data that we collected back in 2021, we found that of the exceedances reported, between 20 to 40% of those exceedances, the wearer reported they weren't wearing any form of respiratory protection. So while we are relying on respiratory protection, we're not using it a lot, and it's not been particularly effective. We also found that a lot of the respirators being used in the workplace weren't being maintained. There were no structured inspection regimes. And we found quite a lot of the gear out there was being compromised, and we really had no idea what sort of protection wearers were getting. We know what they get when you look at the catalogue and from tests done in laboratories, but really there's not much data to indicate what the protection is like out in the workplace after this gear is being used for a number of months or a number of years. And we also found there was a limited use of higher order controls, and I think this came about due to the availability of PAPR. I think people have become complacent and decided to forget about the higher order controls and just rely on the PPE. So we started a tripartite committee earlier on this year, which involved representatives from unions, industry, the regulator, and also we engaged Bruce from Weld Australia to provide subject matter expert input into those guidance meetings. We've run those meetings monthly, and we hope to have a draft comment out for public review by December at the end of this year. We've had input from all the manufacturers of PAPR, On-Tool, Hoods. All those different companies have come along and shared their expert knowledge and information about their products. So we're developing quite a database of information that we'll be able to put into this guidance note, which we hope will provide some very practical guidance on not just how to monitor welding fume, but also how to control it. So as far as the sampling and analysis methods go, our aim is to provide sites the option to choose whether they do task-based or full shift sampling. But what we will be doing is dictating the methods and how that sampling is collected. So it would be referencing Australian standards and ISO standards, and it'll be specifying sample durations, metal analysis methods, and so forth, to make sure that the results that come out at the end are valid and they're reliable, and they can be used to estimate what exposures are accurately. For example, AS 3853, which most of you may be familiar with, explains and outlines the requirements for doing sampling of airborne particulates, specifically for welding fume. It was rescinded back in 2022, and we've got a subgroup within our committee who are looking into this, and have also done a gap analysis against the ISO standard 10882, which was recently reviewed and released last month. If you go through and do the gap analysis, as I understand, reported back from this subgroup, it's pretty much identical to the previous Australian standard in most respects. The minor changes are that it puts a little bit more emphasis around choosing a range of inhalable or respirable fraction sampling devices, but it makes clear that those devices have to comply with the ISO standard 770H08, which defines the respirable and inhalable convention size fraction curves and how they should be measured. In our guidance note, I suspect what we'll probably put in there is, rather than just saying it's got to comply, we'll probably require some sort of certification by an independent testing organisation. The other interesting thing in there, which is different to the old Australian standard, is that it specifies that the sampling, whilst it should be positioned behind the welding chute, which is the same as the Australian standard, it does state that it should be put outside of any form of PAPR or respiratory protection. And that makes sense because we don't have a valid method for sampling inside devices like that. The methods are all based on sampling ambient air. And with that, I'll hand back to Perdita.
Thanks, Andrew. So I'm going to quickly talk about the change from workplace exposure standards to workplace exposure limits. So in April earlier this year, Safe Work Australia released the new workplace exposure limits, or WELS, and there is a current transition period up until the 1st of December 2026, when these will, the WELS will then become the new workplace exposure standards. Thanks, Kelly. What does this mean for welding fumes? So we've spoken a lot about different chemical compositions that you might be doing analysis for. So up the top here, we've got the welding fumes not otherwise specified. And obviously there's no change occurring on the 1st of December because that one's already changed. There is a lot on this slide. And I've highlighted in red the ones where there is a reduction. All the rest of them are staying the same. So I'm just going to call out some key ones to be considerate of. So for example, manganese is actually changing to have an exposure standard for inhalable and respirable. So that is different. And you can see also down in, there's one further down as well that is very similar with that. Also importantly with this, we've got chromium-6. So there you can see that we've listed no exposure standard, and that's because chromium-6 is defined as a non-threshold genotoxic carcinogen. It's a bit of a mouthful. We'll probably all get used to this language pretty soon. And they don't have exposure standards set for them. So this is still something that during this transition period, there'll be more guidance around what this means. So really, I'm just kind of calling out at this point in time that there are changes coming. There is work to be done in this space, and it's just really important that people are aware of it. And as Halil mentioned, understanding what the chemical compositions are when you're doing monitoring now, even though these haven't been changed, that these are things to be considerate of when you're doing your monitoring now until the 1st of December 2026. Thanks, Kelly. Oh, sorry, I'm going to pass on to Andrew to talk about what do we already know now that's going to help us in the future as well.
Yeah, so mixed in with the exposure data that we collected from those 52 mines back to 2017, we also collected metal analysis data, which is very useful. But obviously, we only have the few metals that are relevant to the the welding methods that are used in our particular industry. So if you look at manganese and you apply the exposure limit of 1 milligram per cubic meter, which is the current limit, you see that I think it's less than 5% in green. We'll see exceedances for that particular limit. If we then look at the proposed, or the limit that comes into effect in December 2026 in black, which is 0.1 milligrams per cubic metre, you see it goes from about 15 to 20%. And if you then look at the, as I mentioned earlier, the rule of thumb, good hygiene practice of controlling exposures to 50% of the OEL, that would then be 0.05. It gets up to around 20 to 30%. So it's relatively high. And then if you look at the application of shift adjustment, it ends up being around about 4% at the current limit and about 20% at the new limit that comes in 2026. So the shift adjustment doesn't make a big difference. We then have a look at the impact on nickel. So applying the exposure limit 1 milligram per cubic metre, which is should be in green. It's about 1% of the samples exceeding. And then again, if we go to 0.1, it's about the same. And looking at the rule of thumb, 50% of the OEL, it sneaks up to about 1.5%. So this is nothing like the exceedance rates that we see for manganese. We also, and by the way, out of that, there were only very few samples that exceeded. I think in 3 years, there were 9 samples altogether that exceeded 0.05 milligrams per cubic metre. So pretty small exceedance rates. We also had some chromium data that come through. I don't have a graph for that, but the exceedance rates for chromium were similar to nickel. And these were less than about 2 to 5% of the current limit of 0.5 milligrams per cubic metre. So I think if you take that into account and compare it with the exceedances I showed earlier for total welding fume, the limiting factor for the weld methods that we use in our industry is going to be the limit on welding fume, total fume, not so much the metal composition. All right, I'll then hand back to Perdita. Thank you.
Thanks, Andrew. So we're coming to the end of the presentation, and we just wanted to provide a bit of a summary on everything, some of the key points that we discussed. So really importantly, all arc welding processes will produce weld fume. And as we've discussed, there are significant short-term and long-term health effects from that exposure to that weld fume. Bruce spoke a bit about other particular hazards that you need to be considerate of. So for example, when you're welding stainless steel, hard facing or through coatings as well, will produce specific hazards for those kind of coatings that they've got. Really importantly, and I think this links to the reasonably practical part, and I can see a lot of questions coming up about on-torch extraction, is that control requirements will vary depending on the work site and the material being used. Each situation is different. Reasonably practical is around what is for that workplace and that site, and the processes that are being done is appropriate. But regulators do expect the application of the hierarchy of control. And, you know, we've heard from Bruce around waveform. So for me, this is a very new way of controlling exposure and something that I'm going to really something that I will learn more about and get more of an understanding of the quite significant reductions that you get. So that is where we can look at either removing or, as you can see, by substitution, really using a lower fume process, which is going to be really key moving forward. We spoke a lot about engineering controls, what's currently available. We've got your on-torch extraction, and you've also got those flexible presentations as well. And these can be really effective. I mean, particularly with those ones that are well positioned, you can get up to 90%. And there's something that you can really get that information around. And then I think we always playing out, so hopefully it's okay. And then finally, we have PPE at the bottom. It's too bad. I'm happy if someone else to jump in. Yes. Can you hear me? Can you move to the next slide, Kelly?
Perdita, you're just breaking up a little bit there for us all. I'm wondering whether Halil or Andrew, you want to finish off this last slide for us, since we're having trouble hearing Perdita.
Yeah. Can you hear me?
Yes, you're perfect.
Am I okay? Yeah. I suppose this is really wrapping it up. So it's, I think as an industry or as a welding workplace, you need to be conscious of the proposed reductions in the wells, like the exposure standards that are coming up. They will be referred to wells. They're currently referred to as workplace exposure standards. They will be workplace exposure limits. So it is being aware that they are that they're not very far away. 1 December 2026. I think if you're in welding and you should be looking at understanding the constituents to be able to know whether you need to implement further controls. If we went back 5-10 years ago, the advances in terms of on torch, and I know there's been a lot of discussion around on torch, but the advances weren't there in Australia. I think they had moved along in overseas, but they weren't there. So the more we're delving into this, and the more we're looking at controls, the better the control options are going to be. And if there are concerns from people using them, they should be fed back to the supplier so they can be incorporated. But it is looking at reasonably practicable engineering controls and seeing what can be introduced. We're quite conscious of the fact that in some situations, powered air purifying respirators are going to be a control solution, and that's the case. But we are saying you need to look at all the other control options before you come down to those controls to respiratory protection. And really, it is an area that is really crying out for occupational hygiene technical input, and the value from the occupational hygiene area is going to be, or the need for that information is going to be very much valued, as well as input from the welding industry. So to be able to come up with the best solutions and the best control options for that are out there and understanding. Yeah, so I think I might wrap it there and hand it back to you, Kelly.
Okay, great. We have time for some questions, and we've had lots of chat happening and quite a few questions. So I think I'll start with Stuart. He's put 2 comments up in the question section asking basically around what additional engineering or ventilation type control measures could be available to someone doing welding outside of a workshop area. So noting that a lot of the controls we've discussed today are mainly available inside a designated workshop, what suggestions would you have for people welding outside of workshops for controls other than PAPR? I'm not sure who wants to take that question.
I'll start off, I think, Kelly. I think the first thing for people working outdoors need to note is that this is where the risk assessment is important, because as Halil said, you need to consider if the higher order controls are actually practical, and outdoors they may not be. Maybe a fan can be used to move the fume away from where the welding is occurring. However, if that is going to happen, you need to be very careful that you don't blow the fume towards other workers. That said, as Halil has pointed out, in some situations, PAPR, for example, may be your only option. And if we're talking about in a confined space, well, all bets are off there, and you've probably got to have air supplied helmets and the like to deal with the situation. Maybe others can add to that.
Yeah, well, that is the case. It is your assessment that determines the controls, and if you're not impacting anyone else, if your welding fume is outdoor and you're not impacting anyone else, then your powered air purifying respirator might be the appropriate option for the individual. But it is your assessment that should lead down to your appropriate control option.
I'll just add to that. There's now portable on-torch extraction available as well. So there are other options, and a growing area of interest is robotic welding, which Bruce didn't talk about earlier, but we're seeing some growth in that area.
And particularly cobots, Andrew, which are collaborative robots, which are designed to work alongside of welders.
Okay, thanks, Bruce, Halil and Andrew. There's a question here from Jamie about whether there is any information that on-tool LEV is effective when you're welding overhead, noting the natural buoyancy of fume.
I think it's more than natural buoyancy. I think it's the heat of convection will drive the fume up. So out of position, we do know that its effectiveness does drop off. I don't have the figures, but maybe there are people online from suppliers. I don't know whether they've got those figures or not, but yeah, we do know that it does fall off, and that's where your risk assessment and like is important to consider these options. So there may be limited options, but yes, certainly you need to consider what controls are effective at the time with what you're doing.
Yeah, and I just want to add to that, just to say that when we push on torch, I did say so far as is reasonably practicable, and overhead welding has been raised with us as a situation for on torch where it's probably not practicable. But once again, as Bruce said, I'd be pushing you back to the suppliers of those torches to understand that better.
And just on that one, on torch extraction doesn't work with manual either. So I know Stuart has just put a comment up in the chat there again on that point. And that's where the risk assessment is important, and the only option there may be PAPR and a fan. That's it.
Thanks. For the hygienists on the panel, Jen Hines is asking regarding personal monitoring. She understands the Australian standard is on lapel outside of PAPR, where PAPR is being used. What is the appetite for using real time within the PAPR?
We're going to include the use of real time as a form of control monitoring in our guidance note. We also have a recognised standard on monitoring respirable dust called Recognised Standard 14 within our legislation, where we separate out from exposure monitoring. We have a separate section called control monitoring, and the use of real-time monitoring inside PAPR would be fully acceptable for that, as long as it's not being used to, I guess, try and estimate exposures to people long-term in the workplace. So there is appetite for us. And I think it can be very, very useful as a way of verifying control effectiveness.
Just on that one, Andrew, there are a couple of companies have produced portable units you can sit in a factory that actually measure the volume of, or the exposures that people have in the atmosphere. They're only fairly new. I don't know how effective they are or to what levels they go down to. I know of two companies that do that are either have or are planning to market such devices. That said, the international welding community at the moment is in the process of actually developing live analysis systems at the moment, so that when as people are welding and the fume is drawn away, they can report real-time analysis of the fume coming off. Now, it's still in its infancy, that sort of technology. I know the Germans are developing it's laser based in some way, shape or form. It's a case of watching this space on that one.
Thanks, Bruce. There is a question for you, Bruce, about whether there's any move in industry for incorporating training for new apprentices on using on-torch extraction so that they're more used to it when they go into industry.
To answer that one, I haven't heard of anything happening at this stage, but I would suggest it's a case of watch this space. Most welding training actually happens in TAFEs, and TAFEs have very well set up booths and the like, where they've got plumbed systems in their welding bays, and are very well set up because they're often just welding very short lengths in those training bays. But it's a question that Weld Australia, I think, will definitely take on notice through their connections with the various TAFEs around the country, because it may in fact be an option for the suppliers of this equipment to start talking to the different TAFEs to just introduce that sort of technology to the into the local TAFE system.
Thanks.
As a regulator, we would encourage it.
I don't think we'd have to encourage it too much for it to be considered either, Halil.
Okay, well, that went quickly. I thought we might get some more questions answered, but we've pretty much run out of time. I did want to have a quick plug for the AIOH's Breathe Freely resources and website, and they do actually include some links to the World Australia guidance documents that you referred to in today's presentation, Bruce. So that's a great resource for people to go to the AIOH Breathe Freely site for more information. But having said that, I would really like to thank our presenters today, Perdita, Bruce, Halil, and Andrew. Thank you very much for taking, I know, a lot of time to work together to prepare this presentation for us today. It's come together nicely, and I think people have obviously enjoyed the presentation. There's been a lot of interaction and a lot of good questions. So thank you very much. And a thank you to the AIOH office and Kelly Pfeiffer's as well for all her work in putting together and organising this presentation. Lots of people have been asking about the recording. The session has been recorded and it will be available in a week or so on the AIOH website. So there is a survey that will come up shortly when we end the official part of this session. So please fill that in for us. We really appreciate getting your feedback on how you have enjoyed or how we could improve our webinars in the future. So thank you again to our panelists, Perdita, Bruce, Halil, and Andrew, and enjoy your weekends.
Thank you, everybody, and thank you for attending.